Hello and welcome again. Uh, in the online lecture series, we are discussing the subject Industrial Engineering of BTech Mechanical 6M, and the topic we are covering is right now section 3 in quality management. So, in quality management, we will be discussing about the aspects of quality, what is quality and what is quality management, how quality is measured, and what are the tools and techniques that are applied to find the quality of a product, part, or services. So, what is quality management? So, before coming to quality management, we must be knowing definition of quality. What is quality? So, quality in general is known as fitness for purpose. Quality of a part or product means that if it is able to perform its job well, then it is known to have a good quality product. And similarly, the, another definition of quality is conformance of requirements. That means when it conforms to its requirements. If I my requirements are to take lecture, or my requirement is to uh, my job requirement is to teach you well. If I am confirming the standards, I am forming, I am giving good lectures, I am teaching you good, then then I must have good quality, then I must be a good quality product. Similarly, conformance to requirement means for a product, if it is able to confirm, if it's able to perform the duties and jobs assigned to it, uh, then it is known as a good quality product. Hence, the attributes conformance of requirement, the product should meet the standard set up for it. Hence, the attributes of the product should conform the standards fixed. So, the properties it must have in order to produce the desired requirements, to produce the desired standards. Then, degree of excellence, another methods, another definition is quality is degree of excellence. How much excellence a part has, a product has, a person has, is known to have degree of excellence. So similarly, we can say about any particular student or particular faculty or anything. We can say if we are having that, if we are being measured on a scale, and if we are how much efficient or how much excellence with we are delivering, then it is known as degree of excellence, and then it is called as quality, good quality product. The quality is a measure of degree of excellence of the product. And then grade is also another feature that can be taken. Grade, what grade do we are acquiring in teaching, in learning. Similarly, the products or parts, A grade parts, B grade parts, C grade parts, that would depend on the level that that a part or a person is achieving. So, achievability of the features like appearance, light, performance, reliability, maintainability, etc., contribute to the grade of a part. So, these are the factors that are considered for defining the grade of a part. Now, quality assurance system, we have basically two types of system. One is called quality assurance system, another called is quality control system. I would explain in this way that we that Indian system, Indian education system will be discussing. So in this system, we are having quality control system, whereas American system is called as quality assurance system, can be called, because in quality assurance, before producing the raw material, we must ensure that the part or product or uh, uh, the produce has the required quality conformance. Uh, this is called quality assurance system, whereas in quality control system, the part is produced, but the quality is gauged and measured afterwards it's produced. So it may or may not conform the standards. So this is called quality control system, and quality assurance is basically quality is built or quality is introduced, injected at the time of manufacturing only. So in American education system, at the time of education, they ensure that the product, that the student who has raised, mm, who is under the subject of TT, under the subject of education, must be able to deliver excellence in his life once he is passed out. So that is quality assurance system. And quality control system is like ours. We are giving you lectures and then we are checking at the testing you, examining you at the end of semester. That is quality assurance system, quality control system. So right now, as far as manufacturing industry is concerned, quality control system is obsolete and it is not taken anymore. But for the purpose of future improvements and for the purpose of uh, enhancing quality of the product, the quality control tools are still very much prevalent, and they are techniques used for improving the quality of a product. Whereas the quality assurance system are more prevalent nowadays in manufacturing and service sectors, so that the quality of the product or services are built at the time of manufacturing only, so that the part that is produced is nowhere near the reaction or is a good product or good part. So the quality assurance system is known as system responsible for the degree of excellence of a part or product. Similarly, the whole system concept of conceiving quality into the product at different stages of production. This is quality assurance system. Then what are the different stages when the quality is built? First of all, design stage. As we know, the design stage is the first step of the product to be produced. So initially we design a part. So design aspect or design should be such a good that it does not produce bad quality. So 90% quality is infused when the design is taken. So for what type of design we are producing the part is very important. So design stage is very important, and 90% good quality is injected, or a good quality component or part is designed, is basically conceived at the design stage only. So a good design that fulfills the need of the customer. Then manufacturing stage, once we design and then we come to the manufacturing, then there are different processes, various process manufacturing processes that are used to conceive the to use to produce the part, and quality is conceived in that manufacturing processes or stages that are basically uh, inbuilt the inbuilt quality for producing a good quality component. To check whether the quality of the products manufactured conforms to design specification. Manufacturing stage is the process of converting the raw material into final stage, also called uh, value addition processes, also called value addition. So at that stage, we also try to inject and conceive the good quality in the part. So that has also that manufacturing stage also plays a role for quality product, then field observations, reliability and performance analysis to record the conditions and analyze the data for future improvements. So these are the field observations once the product is manufactured and it is ready for the service. So at that time we take various aspects, what how much it's perform, how does it perform, and then what's its reliability, because that is also a very core concern, uh, especially in the fields where we have human life is at stake. For example, automobile components, and if any part fail and the vehicle is moving at a speed of 100 or 120 kilometers, and if a certain part fails, there are chances that human life will also matter. So in that case, reliability is also a very much important factor. And similarly, the ceiling fan we are having on our head rotating at a high speed. So if any part fails and it directly come to our head, and this way we will be suffering. So reliability we have to take care of, especially in the case where we are exposed to these parts, fires, etc., accidents, etc. So we have to cover the field observations, reliability and performance analysis in the products where the human life is at stake. And then uh, this was this constitutes the quality systems: design stage, manufacturing, and then after manufacturing or the running observations, field observations. So these three constitute the quality aspects of a quality assurance system. So Design stage, as I discussed, is very crucial and important stage. And at this point, at this stage, most of the quality is injected. And when the design stage is good stage, when this passes with smoothly, and this stage conceives a good quality into the product, the chances are that it will long last, and the manufacturing stage will also, and field observation will also play roles. But design stage has more quality aspects and more reliability aspects as compared to other factors. So this constitutes quality assurance. So this all can be submitted: total quality of the assurance, quality of design, quality of manufacturing, and quality of performance. So these are calculated. Now total cost of quality of assurance. So this is we have to take care for a good quality product. Now we are coming to cost of quality. So we can see cost versus quality. So value of quality, this is the part, this is the graph that is drawn between quality and cost. So what we do, we start producing a zero quality product at zero cost, then we keep on increasing the quality, keep on increasing the quality, keep on increasing the quality. So it achieves at one point, it is constantly increasing, exponentially increasing. It is not increasing directly proportional. That means we have to invest much in quality, investment cost. But at the time, there is a saturation point, and then it does not exceed, and it starts coming down. So that is a point that quality, for achieving quality, a certain specific cost is applied. So this way we have drawn two graphs. One is known as value of quality, another is cost of quality. The value of quality, this is the graph, and then cost of quality. So this is the graph. So we have drawn two graphs, and these two might meet at a certain point. This point is exact the quality point, and with an optimal condition of quality cost. So this way we are not having investing too much, appropriate is spending, appropriate spending of the cost, and very good quality parts. So this is cost versus quality. Cost of quality is summation of market research of discovering good quality needs, product research. So this way, cost of quality is summation of how cost of quality is calculated, and these are the parameters that are taken for consideration of cost of quality. One is marketing research cost, then product research and development cost, then design cost, cost of manufacturing planning, cost of inspection and test, cost of defect prevention, cost of scrap and quality failures, cost of quality assurances. These are the costs that are accumulated in order to calculate the cost of the quality and field service. So from the starting, we discuss that market research cost of discovering quality needs. So we have to launch an automobile. So for that, first of all, we have to study the market condition. We have to research the market, what the people want, how they want their car to be. So these are the features that they want, and then we uh, survey from the market, and we ask and give a questionnaire to the customers, to the relative customers. Then what they do, they fill up the questionnaire, and then they tell what features they do need in their new automobile. So this is the market research. Then product research and development cost. Then according to the market research, according to the market needs, the product is developed, and this way uh, the cost procured, the cost invested in product research and development is taken also for consideration of the quality of cost. Then third, we have design cost. So we design accordingly. So once we have produced Once we have designed the product, is invested, and the cost procured is also summation of cost. So this is also taken for the cost of quantity. So this is also added up. Then cost of manufacturing planning, how PPC, that is production planning and control, how the product is manufactured, that is also cost. Then cost of inspection and testing. Inspection is done, testing is done, so results are there. Cost of defect prevention, so cost of scrap and quality failures. So many times the product is failed because of non-conformance to the specifications, that makes the product scrap, and this way it is thrown away and it does not perform. So this is cost of scrap and quality failures. Then cost of quality assurance also for the futures. For the future, there is uh, there is different there is a different aspects that ensure that quality is improved and enhanced. So also cost incurred, and then field service, how much the money is invested while servicing a bad product. So all these are considered, all these are summed up for taking the cost of quality. Now come the So this was about cost of quality. Third aspect we are coming to is statistical quality control. Then we have, normally, if we are producing 10,000 parts per day, 10,000 parts per day, it's not possible to check all the 10,000 parts. Even if it is possible, then it would be taking too much time, too much efforts, and too much cost at the same time. So rather than what we do, we checking 10,000, rather than checking 10,000 parts, we check 1,000 or 1,000 or 500 parts. And these 500 parts or 1,000 parts will be representing the 10,000 parts. The sample is so chosen that actually it represents all the population. So statistical quality control is the technique of reducing the number of inspection and testings in accordance to population. So this is called statistical quality control. The techniques used in SQC are statistical and are based on statics. So these are the techniques that are used and hence known as statistical quality control. Statistical quality control system consists of inspection, testing, and analysis to conclude the degree of closeness of to the standards. That means basically, if we are checking, if we are testing quality of a product, so the quality control system includes inspection of the part, then testing. Inspection may be visual, maybe by some scientific method, similarly testing, maybe manual, or mostly it is by some devices. Then analysis, what result we find, then analyze by applying different techniques and tools of SQC that we'll be discussing in the coming lectures, that the so that the features obtained are analyzed, and then only we conclude what is the quality of the product, what is the degree of quality of the product. So how much it is close to the standards. So in future we take care to bring it to more close to the standards, so that it targets exactly the standards. That's our motto, and that is the role of statistical quality control. SQC was developed in 1924. This is a proven scientifically determined database system, control system, so that the quality of a product is checked. One more thing, it is based on probabilistic theory of statistical techniques. So probabilistic theories and evaluates batch quality and controls the processes and products. SQC consists of three scientifically techniques: sampling section, analysis of data, and control charting. Statistical quality control consists of three techniques, that are analytical and scientific and mathematical techniques. One is sampling inspection, analysis of data, and then control charting. Sampling inspection means that we have reduced the 10,000 inspections to 500,000. So the art of reducing the 10,000 to 1,000 or 500 samples is known as sampling. Sampling means that we have to take only 500 samples out of 10,000. And how do we choose the sample so that they represent the whole population is art and is the science. So we have sampling plans, single sampling plans, double sampling plans, different sampling plans. So for that we use sampling plans to put up or pick the part that we are going to inspect. Sampling inspection, then analysis of data. After testing, after inspection, data is achieved, and this data is analyzed to find the quality of the product. Then we have control charting. That means after getting data, what we do, we make different control charts, and these control charts are used for future plans, for future quality enhancements. So we'll be discussing sampling inspection, analysis of data, and control charting in these few lectures. Then first is sampling inspection, sampling plan. 10% inspection is tiring and costly. At the same time, as I discussed, 10,000 parts cannot be possible, is not possible to check. So for that, we need a few samples that basically represent the true population, true the whole population. Then the aspects are cost effective, time saving, and reduced effort technique. The data is collected by applying sampling. One more thing I wanted to tell about sampling is that many times there are destructive testing. That means we have to destruct, we have to, for to check the quality, we have to destruct the part. So if we apply 10% inspection, no product will be saved and all the products are to be broken or to be destructed. So destructive testing also needs sampling, because what we do for test for test we need, we take few samples rather than 100%. If we take 100%, there will be no part save, survived. So all the, because this is a destructive testing, so part is destructed. So for example, automobiles, we analyze destructive testing. So there we apply several destructive techniques in order to check the automobile. So if we destruct all the parts, what would we sell? So in out of 10,000, we take one and we destruct it. So this is the absolute necessary for the products where we apply destructive testing. So this was the sampling technology, sampling technique, then analysis. Of course, what we have achieved will be analyzed, and then control charts we will be making for future or current batch. So we'll be discussing different types of control charting in our next lecture. So for the time being, I will tell two more things about this QC. The statistical quality control has two types of inspection. One is by attribute, one is by variables. Attributes are the non-measurable aspects like luster, like taste, like uh, beauty. These cannot be measured. If a product is beautiful or not, if the product has more luster or not, if the product is more straight or not. So these are the attributes where true, false, yes or no can be written in a column. Okay, not okay. So these are the qualities of a product that are that cannot be measured are known as attributes, whereas the qualities that can be measured by certain on certain scale are known as variables. So we have different types of charts for attributes and variables, and we will be discussing in our next lecture. For the time being, I am signing off. If you have any problem regarding any basic concept or data or you're not getting, you may get in touch with me at my phone number 9069360400. So for the time being, I'm signing off. Okay.